Dear students, in this very, very important video, I'll be supplying some important definitions of things like walk, trail, path, closed walk, cycle, length of a path, length of a walk, and length of a cycle. These facts are very important in learning advanced graph theoretical concepts. So very, very carefully you have to observe all the definitions, because I must emphasize the fact that in order to learn a result, a theorem, or a proposition, whatever that comes after this video, these definitions are fundamental building blocks of those higher concepts. So once again, let me remind you that no definition should be carelessly observed, it should be carefully watched. So this is the first definition. You are given a graph G. A walk W in that graph G is an alternating sequence of vertices and edges in such a way that if W is V0, E1, V1, E2, V2, etc., Vk minus 1, Ek, Vk. So V's are representing vertices and E's represent edges. The edge Ei is incident with the preceding vertex Vi minus 1 and the succeeding vertex Vi. I'll give you an example. Before that, let me define what we mean by length of a walk. The number of edges in a walk is called length. Okay, so let's have a graph first. Very simple graph I'm taking. This is my graph. So let me have this graph like this, and let me mark the vertices as A, B, C, D, E. Let me mark the edge. This as E1, this is E2, this is E3, this is E4, this is E5. So in order to construct a walk, what we have to do? You have to start from a vertex. So let me start with the vertex A. So I have started with A. So I'm here now. Now let me move over the edge E1. So I have to write E1. Then I have reached where? At C. So I have to write C. So that you see A and C are end vertices of E1. Now let me move along E2. Or this is E3 rather, this is E3. So let me move over E3. So that C is a, so E3, then what is the end vertex of that? It is D. So I have reached here. So I can say A, E1, C, E3, D is a walk in this graph. So it starts with a vertex, ends with a vertex, and these are the edges. So length of this walk is 2. So I have crossed over from A to D by using the edges E1 and E3, and in between I have traveled over the vertex C also. This A is called initial vertex of the walk and D is called final vertex of the walk. Length of the walk here is 2. Okay. A walk of length 0 is a single vertex. So if we have a W which is simply a vertex V, we say this is a walk of length 0. There is no edge at all. Okay. Trail is the next definition. Walk in which no edge is repeated. Very carefully understand. If you have a walk in which no edge is repeated, that kind of walk is called a trail. Trail will come in a later chapter when we deal with Eulerian graphs. Okay. So for that definition, we have to wait for some time when that chapter comes up. So anyhow, this path is very, very important. Even if you forget the definition of walk, unless you learn walk, you cannot learn path. But path is very important. A walk in which no vertex is repeated. See the difference between trail and path. Trail means no edge is repeated, and if no vertex is repeated, then that kind of walk is called a path. If no vertex is repeated, definitely edge also will not be repeated. That's an important thing. In the case of a trail, edge, a vertex may be repeated. So let us have an example. So let us consider this. So this, let me call this vertex as V1, this is V2, this is V3 and V4. So this is my edge. Let me mark it by some other color. This is E1, this is E2, this is E3, this is E4. There are 4 edges and 4 vertices. Anyhow, let me start with V2. I have started with V2. I have moved over to E2, so it is V2, E2, V3. Then moving over E4, so I have reached V4. Now I'm here. Now I'm moving back to E3. It is E3. Then I'll be reaching at V2 again. Let me move to E1. So it is V1. E1, V1. So I have started with V2, ending at V1, but you see no edges repeated. E2 appears only once, E4 appears only once, E3 appears only once. But what happened is vertex V2 is repeated twice. I'm starting with V2 and I have reached V2 again back here, moving here, then move. I've reached here once again, then I'm traveling here. So such vertex may be repeated and edge cannot be repeated. Then that is an example of a trail. But in a path, no vertex and no edge must be repeated. That's an example of a path. Okay. So in this, I can take V1, E1, V2, E2, V3. So it's a path having edges E1 and E2 and vertices V1, V2 and V3. Nothing is V1, V2, V3 are different, E1 and E2 are different. So I can call this as a path of length 2. Okay. Closed walk, a walk W, you know it's an alternating sequence of vertices and edges. It should start with a vertex, end with a vertex. In between we will have edges. It's said to be a closed if initial vertex and final vertex coincide. This initial vertex V0 must be coincide with Vk, so that means Vk must be equal to V0. Then we call this such a walk as closed walk. An example, here is a graph. Okay, so I am starting from here. Let me mark it with a different color. I'm starting from here, moving here, then moving here, moving here, moving here, moving here, back to the first one. So I'm traveling, you carefully note, moved from here to this, then here, then I've reached here, then finally coming back to the original. So from where you have started, you have to reach back. Such walk is what we call it as closed walk. Okay. So cycle is very important. A cycle in a graph is a closed walk where no other vertices except the initial and final vertices, and hence no edges are repeated. So if we have a closed walk in which the initial vertex and the final vertex are same and no other vertices are repeated and no other edges are repeated, then such a closed walk is what we call it as cycle. For example, in this graph, let me draw it with a, this one, I'm starting from here, reached here, so I have moved over an edge, reached here, move, so this is, then I have started come back. So this is an example of a cycle. Okay. Length of a path and similarly length of a cycle, as I have already mentioned, is the number of edges in them. So now let me give a notation also. Pn is a path of, it is a graph actually, it's a graph of n vertices. So this is an example of a P4. This is V1 edge, then V2 another edge, V3 another edge, then V4. So this is P4. So generally Pn will be like this, a vertex, E1, then V2. So let me start with this. EV0, this is V1, then E2, etc. Then it will be having Vn minus 1, En, Vn. So there will be N. Sorry, I made a mistake. So it must be, yeah, Vn minus 1. It should end with Vn minus 1. There will be only N minus 1 edges. So, okay. There is E1, etc. This will be last, but one will be Vn minus 2, En minus 1, then Vn minus 1. So if let me move it like this, let me clear it completely. Clear the spread. So Pn is a notation for a path, a graph of n vertices. N vertices are there, totally n numbers, and how many edges? N minus 1 edges. So no vertex will be, so you have to start with a vertex and with a, it is not a closed walk, it is a complete path starting with a vertex V1, then an edge, then another vertex, and an edge, like that. So if there are n vertices and n minus n edges, a structure like this or a graph like this is what we denote by Pn is the graph actually. Similarly, if you have a cycle, having say, this is an example of a C5. Means you have to start with a vertex, move on to an edge, reach a vertex, move on to an edge, reach a vertex, move on to an. So there are 5 vertices and 5 edges. So such a structure is what we call as a cycle. One more example, if I have, say, here how many vertices? 7 vertices. Move from one vertex, reach to the second vertex, go on like this, coming back to this. So it's a closed walk. So as it is containing 7, this is the notation for C1. So C7 is a cycle of length 7, having 7 vertices and 7 edges. With this, we end this video. Every definition is very important, and you have to carefully notice and watch everything.